let's start with the webinar. So this webinar will strongly focus on software and how to implement the tools that are built in to CrysAlis Pro for the variable temperature experiments. So what is usually motivation for such experiments? In most cases is to either avoid problematic data sets or to study the phase transition in crystals. By avoiding problematic data sets, I mean to find the temperature where your sample, your crystal, will not show twinning or will be in phase that will not be, in, for example, incommensurate. But also those tools allows for quite big automation of data collections, and that can be also used in advance for your workflow. So how to start the temperature experiments? Like always in CrysAlis Pro, you follow the same workflow. You start with the start-stop button, and in this case, you go to the other experiments, and then you will see the temperature experiments. Of course, there is a shortcut button on the left side if you want to direct access the tool. The tool is straightforward and you can enable the temperature control device by selecting this tool and then select the proper device from the drop list. On the drop list, you will see lots of instruments which CrysAlis Pro support to talk with during data collection. We still expanding them, and there are lots of legacy instruments, but also the newest one available on the market. I want to also mention that this part of talk will extend also to non-standard data collections, but for this webinar, we will focus mostly on the single crystal dataset, but the same software adjustments and settings can be used in a powder experiment dialog. An excellent webinar recorded by our co-host Christian Schulman is available already online, which explains how to use and how to perform micro XRD with single crystal diffractometer. So let's go and see what are available settings for the control. And the tool is quite easy build. It's usually a list of strategy of your temperature, and you can add them, edit, delete tool. So before I explain more, I want to quickly show you how the experiments are saved on the disk. They are just each of the points that we define temperature points are separate folders and separate experimental classic CrysAlis Pro experiments that you can open separately or batch process them, as I will show you at the end of this tool. So you can see that the first digit of the folder correlate to the point. So even if we have the same temperatures, the folder will stay segregated in order as it should be. So let's go to the tool now and explain the settings on the instrument itself. So as I mentioned, you can delete or add experiment. When you select add experiment, what is the most obvious? You select the temperature and the ramp rate. So as you can see, these parameters will change depending on the instrument that you select. So this will not allow me to put anything that doesn't make sense. So this is already take care of it. And then there are several weighting options, one for reaching temperature and the other one for the stabilization. And there are a few combinations of it, and we'll discuss how to use those to your advantages. Also, each experiment can be, each point can actually perform data collection in one of the defined strategies or not, and you can decide if you want to record movie or not. So if we decided to add one, let's say starting with standard setting 100 Kelvin, what I do always in the lab data collection. Then we have one list. So of course we can click add another one step and another one step, but there is a quicker version of doing that. You can just select the first input and click expand selected, and then you have access to this kind of simple dialog where you can define what you want to reach. So in our case, let's go to 280 kelvins, so just above the zero, and then use 20-degree steps. And here we go. The software generates exactly copy the same of instruments. So if I decided that I want to copy this one and edit it and decide to not perform, but just wait additional, for example, 10 minutes to allow the sample to recover from cooling up. And then let's say I want to again cool down the sample. So I can select this one. So I will move this one up and select this one. And it's part selected. But now I want to go back to 100. But maybe I'm not interested in such a small step. I just want to quickly get there. So I will use a larger step. But of course, now I'm coming down with the temperature. So I have to add minus here. And here you go. The CrysAlis Pro added extra steps. So of course, we can export this to the format, editable format by Notepad, or then you can import it and you can append already made list or just copy clipboard to do it. If someone prefers Celsius over Kelvins, we can switch the settings. So a very easy to use tool. And now I would like to go back to my slides and talk a little bit what kind of cases will be available, how I recommend to use the tool and what cases. So the one that we just covered a few seconds ago is the classic screening for reversible phase transition. So we're starting with the, let's say, slightly, almost slightly below zero, go to 100 and then go back to the other transition. And every time we perform the same strategy and just giving extra time for the stabilization for the tool in the settings. So the other case that I actually prefer, because it's usually quicker, it doesn't stress so much on data collections, is to prefer initial temperature strategy and the same strategy in the low temperature, and that could be probably complete data collection strategy. And then in between, just collect strategy 2, which probably will just collect some pre-experiment already saved single file scan or just axial scan to observe if and on what temperature range that the change between already known from me between the 200 and the 100 Kelvin temperature will change. That will be case 2. Case 3 is quite interesting. That'll be by extremely quick new generation of instruments that allows you to collect very quickly data. That will make it very hard to check the ramp temperature, stabilize the instruments. So what I always do in such a case, I'm checking both weighting for the temperature, select the fastest possible ramp rate, select the target temperature, and just copy the same settings over and over to achieve some number of temperature points that I think that probably will be enough looking on the ramp rate to cover the region that I want to have. So of course your experiment then will look like this, and each of the folder will have 100 Kelvins as a designated temperature. There is order in them, but no problem. If you open this experiment, the CrysAlis Pro will record the sample temperature or the range that the measure was. So that was some data collection that took a minute and a half, and this is the connected to the ramp rate temperature average one. So this will allow you, if you choose just file scan or just screening scan, will allows you to very fast go through the extremely large range of temperature with small steps, and then realize where exactly the phase transitions happen on the ranges of temperature. So it's not only screening. I just want to point out that also, this is collected also the RGS with the HiPeak 6000, and this is our classic what is this experiment. And like you see, the dose time was just 11 seconds, total time 29 seconds. This is almost organic. We have a sulfur there structure, but also non-central symmetric space group. And it's enough to get enough data to solve the structure for good diffracting, good quality crystal. So we can imagine that if you have a material that have multiple phases, you can apply this strategy, temperature case, and select this kind of strategy and actually solve the structure multiply, especially with the AutoCAD pipeline that will do all the work behind you, for you in the background. So one quick hardware tip for you: if you have access to CryoStream, CryoStream usually supports so-called turbo mode. It puts some stress on the pump, but that's really something that you have to be worried about when you work only limited time with it. But what you can do when you enable it in the dialog window in CrysAlis Pro, you can double the flow or the mass flow of your gas. And thanks for that, you see also gas heat indicator goes up. That means that we have better performance of our cooling device, and that basically allows us to reach temperatures faster and to achieve to reach to lower temperatures. And if your instrument is not so fast as new Synergy, it allows you to actually collect in narrower temperature range. So that I said will cover lower narrow temperature changes. So another case that I sometimes use is to avoid shock cooling or delay measurement and allow crystal to slowly cool down. So this is the case when I will set up the crystal, allow to slowly rub, and then just wait an hour additional, and only that after I will run a second experiment that will collect data. So do you think that it's not often happening, but it's happening? For example, this is the crystal that the crystals were looking nice under the microscope, but every time I were putting them under the cryo, they were changing and basically dissolving. And I did quickly this kind of case when I rub down the cryo and check for the quality or just basically single file scan. And I realized that in 180 kelvins, the crystal is okay. And just below the 180 kelvins, the crystal decomposes. In this case, I didn't try to slowly cool it down. It was enough for me to collect in 180 kelvins, but it allows me to collect the crystal that in the first appearance looks like they are all bad and they are all decomposed material, not single crystal. But the problem was actually that the crystal was decomposing probably through the low temperature or shock cooling. Case 5 is sometimes very often asked by users is how to force CrysAlis Pro to collect movie before and after the experiments. You can just use the temperature tool and select those two options. And then this is useful, for example, when you have a crystal that now it will be damaged by radiation, and that very often shown by changing some color or darkening the crystal, and you want to have visual visual confirmation that it happened. Or maybe you think that the crystal slowly changed the phase during measurements and also will display some changes in the color because of that. And for example, you can also use this as an automation tool to queuing two different strategies at once. So let's say that you have a crystal that is not diffracting well on your instrument, but you are not sure what it is. But this button will tell you that the strategy for crystal solution will take you probably 2 hours, and you really have to leave the lab, go on the meeting, or attend other things. But you cannot get back here at the time to change the sample or switch to the other strategy. At that point, you can just select the first strategy as what it is strategy, and the second one as a complete high quality DC strategy. After the time that you have chance to come back to the instrument, you should at least have the first strategy ended, and allows you to cancel, change sample, or collect data or continue collect data on the crystal without losing time. But you should at least have a low intensity, so 60%. I to sigma 5, that's the target that usually shorten that data strategy a very lot. And it could be even shorter than the beginning of your second strategy to get the solution and confirmation of the sample composition. So how to add those strategies that I'm talking about? So when you set up your temperature list, you can access strategy 1 or strategy 2. The second button will engage when you select those options in one of your points. And then you can choose the strategy. So what I strongly recommend always is to either perform the standard screening and pre-experiment procedure. Then you will have correct cell in this tool, and then you can calculate and change strategy yourself as you do for the normal experiment. Alternatively, you can import the pre-experiment files that you just collected, or screening run list that you just run, and then use this as one of your strategies. You can, of course, create earlier desired file scan or some other different available scan for your system and perform those for your experiment. But I really recommend to run the pre-experiment and remember to adjust the other strategy settings, especially like detector settings. For high peaks, it will so the pixel detectors, it will be the dynamic range mode and the frequency, but CCDs detectors also have the sensitivity and binding modes. Also important settings to adjust before you start data collection. But of course, the more advanced and the interesting part is to use and create scans yourself. And here I want to just mention that is few useful options. The first, use inverse scanning direction. So if we think about the case that do very quick, rapid scans, if you select one file scan in one from 0 to 10, then the second strategy can be actually the same file scan, but you click inverse scanning direction, and then what the system will do will collect 0 to 10 and then save the frames backwards. So you will not even lose time for returning with your goniometer back to the original position. Of course, that's only possible in the shuttleless mode or the new generation of the system. And also, quite important option for the temperature studies, if you want to do snap each frames, if you select very wide frames just to catch some orientation or maybe axial scan, that is nice to add to the video frame, just one frame, not the whole movie, which usually is faster, especially when you collect such a fast screening scans and you don't have time to drive the goniometer to the video position and record the whole movie. So let's see and discuss those options again. So I will close this one, and you see I have strategy, and you should be familiar with this window. As I mentioned, you can calculate strategy here normally, but as I mentioned, because we didn't do the pre-experiment, I don't have access to the experimental settings of the detector. I will have to now guess it or expect it. Also, the type prediction are not here. That's why I always recommend to import already strategy that is somewhere saved for you already on the disk. But also you can just select all rights, delete it, and decided to add one of the 5 scads. As I mentioned, the click here is again. So I'm adding first scan exactly the same. Then I can decide to select a new, and I have the same scad, and I just do inverse one. So those scads will wobble one back forward. So they look the same, they will be processed the same. It's only the effect of data collection. You see there is bias here, add with. Other options, as I mentioned, is you can add the video snap, and then the V will show. If I add classic Omega SCAD with the video snap, then you will add also the V. This is how you recognize that for each frames there will be also image of the crystal capture. So you can always test for collisions. So this is still protected mode. So no matter what you do, the system will try to avoid the collision. So if you play dice, it will always give you options. So here's your bidding options if you need, and classic all the things that if you never done it manually, there is a help button that will guide you, but I think I covered the basics how to do it. So let's go back to slides, and I want to show you a few things that I know lots of users ask about. One of that is influence of temperature for the sample holder. So I made some pictures for you on classic nitrogen mount or loop, and you can see that in case of the low temperature from 85 to basically 200, the shift is only around 10-20 microns. So if you keep your crystal in the full width height of your beam, which for Synergy S, the new generation of the system of Synergy S, it will be around 110 micron. You will see that small offset will be not a problem for CrysAlis Pro to handle it as a crystal wobbling or eccentric. But if you decided to use a hot blower or temperature, those sometimes will change a lot, as you can see. And then if the crystal is small, that can influence your results, especially if you're planning to check if you're observing changes in your cell dimension. What is your point? So you should be always remember that you can change the modes, and there are modes that will be less influenced by the temperature. But for the standard measurements, especially in a low temperature, I will not make very concerns. But there are few tips and rules that I will always recommend. First of all, use a fresh, clean mount if possible, especially rushing your sample through this turbo mode stream with the bigger flow will cause a lot of turbulence. Every additional oil or some dust or unnecessary particles will cause more turbulence and can end up with the icing that you don't want to see on your sample. You also should make sure that the tip that your mount is rigid enough for your sample. So if you mount a big crystal and use a very small nylon loop, you will see that in some orientation your crystal can be basically wobbling because of the force of the gas stream itself. Also, please don't forget that the oil that you use for collecting in low temperatures, like 90 or 95 kelvins or even 150 kelvins, is okay because it allows good interface to your crystal or sample to your mount, but it can be less effective already in 280 kelvins. And even that the loop itself will not expand a lot. Basically what is expanding is the metal part under the loop. The crystal actually can slide down or the other way around. So that's why I also recommend for data measurements to not try to put the crystal on top or next to the loop like we usually recommend to avoid additional both material in the beam. Usually just put it flat or inside the loop, secure it very good, so you are sure that the crystal will not move away when you changing the temperature. Also, if you have a big crystal, it's better just put it, and there have one big face, just put it flat, support it with the whole loop using glue that will stand your temperature, or just grease to make sure that it sticks to the loop. So in most cases, there's nothing really to explain, because as you probably, as a user of CrysAlis Pro, I hope so, you know that in most cases concurrent data reduction during experience enable and will process the data. But if you actually are doing the phase transition studies, you would like to always start your processing with the same consistent orientation matrix to be sure that you have the same lockdown symmetry settings for yourself, and you tracking the change of your crystal from exactly the same way. To do that, you can use the profit patch tool that can be accessed from the command line. There are two ETS, 59 and 66, which explain nicely how to use it, what are the advantages of it, and why you should use it. And the additional benefit of it is that after this process, batch processing, all changes in parameters will be gathered in one comma separated value file that you can edit in any spreadsheet editor and plot the changes in your unit cell or volume or whatever you were planning to see it. So other option is to use the axial scads or axial photography to align your crystal in some orientation that you prefer, get that information, the orientation of the crystal, and then put the scan, manually scan that you created by hand in your strategy for one of the strategies, temperature strategies that you thought that are useful for you. So, but although the graphic tool is very nice, it gives you more options, I strongly recommend that to get familiar with the command line shortcuts like GTR or GT plane, which allows you to go to the one reflection or the plane that you define, and then you can decide that this position of the crystal or goniometer that you can access using another shortcut, type angles, TI angles, and create the scan that the diffraction condition, desired diffraction condition is the middle of it, and actually fine slice the desired range of reciprocal space very fine to what is possible for your system. So you can even, on new system, you can go to 500 of angle, and with extremely fast detectors that are reaching 100 seconds per readout, you can really you can use short exposure, so data collection is quick, and at the end you will get a full collections of those high resolution scads or reflection, and you will be able to track the changes of the profile of one of the reflection with the temperature. So at the end, I want to just show you how to easily recover some data from this large, very often large list. So as I mentioned, there is a profit batch tool that will do that automatically and export it to the Excel file. But also you can use the select experiment list for this reason. So what I often do, you see, I have even created searches here, but I will select new list from the select experiment on the opening of CrysAlis Pro. Then I will navigate to the folder that holds of my temperature studies. And after selecting it, I will just switch to the custom columns and select the unit cell volume lower group. And of course, here I did notice lots of changes, although something I can see that something happened with the processing at some pages, and then probably this is what I want to investigate what was the problem. But I can quickly check the unit cell and the volume changing if there is existing, and if the volume change corresponds that it was problem with processing or not. and I can correlate that to the temperature what I have here. So that's the easiest way to access your this temperature results if you focus on the small results like volume or unit cell degrees. And then basically bring us to the end of my talk and presentation. I hope you have some questions that I can answer you now.